everyone. Okay, this is a big one. Rearranging and simplifying algebraic expressions and trying to make it easy to understand. This is the one that parents tend to get stuck up on, that algebra is hard. But if you get the idea, it's actually not at all. So, expressions with unknowns can be simplified. To understand this, it's easy to think about it in terms of natural language. If I have x plus 2x, it means 1 lot of x plus 2 lots of x is equal to 3 lots of x. Thus we have this expression here, x plus 2x is 3x. Easy so far. An easy way to confirm this is correct is to do a bit of substitution. So if we let x equal 2 into the expression above, x plus 2x, put 2 where x is, and then evaluate. So 2 plus 4 is 6, 3 plus 6 is 9, and a plus 2a is 3a. 1 lot of a plus 2 lots of a is 3 lots of a. In all cases, the equation is true, the method appears to work. Now, if we have more terms, in this case we have 1 lot of x, we add 2 lots of x, and then we add 2 lots of y, and then we take away 2 lots of x. That will leave us with 2 lots of y, and we'll be short 1 lot of x, or minus 1 lot of x. So let's see if that works. From the last video, we can just rearrange this so that the negative 2x is second. Makes it easy to do the subtraction. X take 2x is negative x, and add 2y. Now, when I was in school, we would rearrange that to put the minus sign at the back so that we reduce the number of symbols that we wrote by 1. We didn't have to write this plus anymore. It's not as common as it used to be. It's not really that big a deal, but that is the convention. So, easy to do when there aren't fractions. What do we do when there are fractions? We talked about this earlier. Here the fractions start. So if we have 12ab on 6b, if we want to simplify it, we split it into multiple smaller fractions. From our arithmetic knowledge, we know that if we're multiplying in the numerator, if we're multiplying multiple fractions, we just multiply the numerators and multiply the denominators. So you can see here we started with 12ab. 12 times a times b is still 12ab. And because we're putting the numbers and the variables together, we have a number, so 12 on 6. We don't have an a in the denominator, so we're just going to put 1 there. And we do have a b in the denominator, so we're going to put the b underneath the b. Now, to simplify that, we're going to use some properties. For the numeric part, we'll use highest common factor and divide as per arithmetic. For the algebraic part, if we have a on 1, we can later say that that's just a. If we have b on b, any number divided by itself is going to be 1. And if we have 1 times a, we're just going to make it a. So here we go, let's apply. 12 on 6, that becomes 2. 12 divided by 6 is 2. Highest common factor is 6 divided into both of them. 2 on 1, which is 2. A on 1 just becomes a, as per this part here. And b on b becomes 1. B on b becomes 1 as per this property here. So we end up with 2 times a times 1, which simply is 2 times 1 is 2 times a is 2a. Simple. So this expression here quite simply becomes this expression here, as I have said there. Now, come back you, I need you. What your parents would have learnt is something like cancelling. So I will show you the cancelling method. It's ugly. 12 on 6 becomes 2. A on 1, well, there's no a on the bottom to cancel out, so we won't cancel that. We have a b on the bottom and a b on the top, so we'll cancel that. And lo and behold, we're left with 2 times a, which is 2a. Now that method's great if you understand what it is that you're doing. But it does get untidy, as you can see from here, quite quickly. Whereas this is remarkably elegant. Now, if there are multiple terms in the numerator, we can split the fraction again. So in this case, we have 12ab take 5. We can make that 12ab take 12ab on 6b here, minus here, 5 on 6b here. And you can see the convention is we write that minus sign between the fractions. Now, that's fine, but where the misconception comes is that we can do the same thing with the denominator, and we most definitely cannot. So the correct way to expand this expression where we've got 2 terms in the denominator is to say that 12ab take 5 is 12ab divided by a plus b, and 5 divided by a plus b. Because what this expression all the way back up here means is divide all the terms in the numerator by 6b. So in this case, divide all the terms in the numerator by 6b. We divided this term in the numerator by 6b, that's this, and we divided this term in the numerator by 6b. What this expression is saying is divide 12ab by a plus b, and then divide negative 5 by a plus b, which is what we've written here. Here's where the error gets made. Students think that this can be expanded to this. 15 divided by a plus b is 15 on a plus 15 on b. That's not what this fraction means. And if you do this, it will create an error. Here's an example. So if I have a half, that can be split into 1 on 1 plus 1. And then if you do what was done here, that becomes 1 on 1 plus 1 on 1, which is 1 plus 1 would be 2. And you'd be saying that a half is equal to 2, which it most definitely is not. And similarly, if we had 1 on 2a, you could say 1 is equal to 1 on a plus a, but then if you split this into 1 on a plus 1 on a, like denominators, add the numerators, you'd be saying that that equals 2a, 2 on a, 1 on 2a cannot equal 2 on a. In both cases here, we've shown that splitting the denominator just does not work. Please don't do it. Right, let's quickly go through some simple cases. And I said earlier that using natural language can help a lot when simplifying algebraic expressions, so we're going to do that here. And we'll look at a case where it doesn't help much, but it doesn't harm either. 2 lots of x plus 3 lots of x is obviously 5 lots of x. 2x plus 3x, 5x. Take the numerators, add them up. 2x plus 3y take 4x. 2 lots of x take 4 lots of x is negative 2 lots of x, plus 3 lots of y is negative 2 lots of x plus 3y. Now here's an interesting one. We call this distributive law and we make a big deal about it, but it's really quite obvious. 2 lots of 2x plus 3. So here's 1 lot of 2x plus 3. Here's 2 lots of 2x plus 3. We rearrange it, we get 2 lots of 2x and 2 lots of 3. That's what I've written here. 2 lots of 2x plus 2 lots of 3 equals 4 lots of x. Now, distributive law just says I can take whatever's outside the bracket and multiply it by what's in the bracket. So 2 times 2x, that's this part. 2 times 3, that's this part. And this is the reason why it works. Then when we simplify this, 2 times 2x is 4x, 2 times 3 is 6. Now here we've got lots of terms, but only some of them are like and can be simplified and some of them can't. We have x's, they can be simplified. This 4xy is not the same as x, it's not the same as y. We cannot simplify it just by adding or subtracting the coefficients. And the same with y. 3y is not the same as this, not the same as this, not like this. Can't do anything with it, just leave it alone. So let's start with what we can do. X minus 2x is minus 1 lot of x, plus our 4 lots of xy, plus our 3 lots of y. And that's where this answer here comes from. Here's our fractional example. Divide 2x plus 6 by 2, so that we're going to divide 2x by 2, which gives us x. We're going to divide 6 by 2, which gives us 3. That's where we did what I said. And in this case, we're going to have 6xy and we're going to divide by 3x. Saying it in this case doesn't really help much. 6 lots of xy divided by 3 lots of x doesn't do much. But we then split it into multiple fractions. 6 on 3, x on x, y on 1. There's no y's in the denominator, so stick 1 there. And then simplify. 3 goes into 6 twice, or divide both by 3. 2 on 1 becomes 2. X on x becomes 1. Y on 1 becomes y. 2 times 1 is 2. The answer is going to be 2y. Now, you've heard me just saying it. Now let me just do it formally. If two terms have the same coefficient, have the same variable, we can add the coefficients, which is what this says. This has an a, this has an a, add the coefficients, add whatever's in front of the a. Where a and b are constants, so not where a and b are constants, that's not right. Where b and c are constants, and a is a variable. Now this works for other cases, but it wouldn't be called collecting like terms then. If the pronumerals are the same in terms, add the coefficients. That's all it is. So 2x plus 3x, the pronumerals or the variables, I just use the word variables here because I've been doing that all the way through. Pronumerals just means the same thing as variables. So the variables are the same, add the coefficients, 2 minus 3 becomes minus 1. 2 plus minus 3 is minus 1. Similarly here, we have like terms minus 2 and 3x. So take the coefficients, add them together. 3 plus minus 2 is the same as 3 minus 2, which is 1. So we have x, and then just add on the 5 as before. Now, distributive law is just collecting like terms backwards. So if we have a term outside a bracket and some terms inside a bracket, multiply the term outside the bracket by all the terms inside the bracket. So in this case, a times b and a times c. So if we have 2 lots of 2x plus 3, that's going to be 2 lots of 2x and 2 lots of 3. 2 lots of 2x, 2 lots of 3. 2 times 2x is 4x, 2 times 3 is 6. Similarly, if we have minus 1 outside the bracket, remembering that if we don't write the 1, it's still there, we just have implied it. Minus 1 times 6 is minus 6. Minus 1 times minus 2x is positive 2x from our negative number information in arithmetic. Negative times negative is positive. Now from here we can see that distributive law is just collecting like terms backwards. They're both connected by commutativity. Once we understand how they work, all is good. Let's go through some examples. Alison has 4 boxes of beads and Mary has 3 boxes of beads. Half the beads in each box were faulty. How many beads did they have? So let x be the number of beads in each box and t be the total number of beads. A be the total number of beads that Alison has and m be the total number of beads that Mary has. So Alison will have 4 lots of boxes. So Alison will have 4 boxes of beads. 4x. That should be m, shouldn't it? M for Mary. Mary has 3 boxes of beads, which will be 3x. 4x plus 3x is 7x, and half of them are faulty. So the number of non-faulty beads number of not faulty beads should be t, shouldn't it? Not faulty beads is 7x on 2. Now, probably not the nicest way of saying it, but it'll work. 4x plus 3x gives us 7x. Now let's just say we had 100 beads in each box. How many beads would they have? So we'd substitute 100 into our equation. That would give us 7 times 100 divided by 2 is 350. They'd have 350 beads that are not faulty. Any not faulty. Let's make it as clear as we can make it. Right. Let's look at this case. We have an equilateral triangle. I might erase all of this from when I was looking at it earlier. I did this whole video and didn't have the volume on, which is not very smart. So if we have 2x plus y and it's equilateral triangle, all sides will be the same length. The perimeter will be 3 lots of 2x plus y. Using distributive law, 3 times 2x is 6x, 3 times y is 3y. We could do this without distributive law. But we can see why distributive rule works, because we've obviously got 3 lots of 2x, which is 6x, and we've got 3 lots of y, which is 3y. Okay, first case done. Second case. Oops, I've done it again. Let's go rub all this out. Try and walk you through it as we do it. So this length is parallel to this side, so it's going to be the same length. This length is parallel to this side, so it's going to be the same length. The perimeter, we've got 2 lots of x plus 3, and we've got 2 lots of 2x plus 7. The perimeter is obviously the length around the outside of the shape. So that's going to be 4x plus 6 plus 4x plus 14, which is 8x plus 20. Done. Oops, I've done it again. So hopefully, I think I've done it for the whole last part of this. So I've got a lot of rubbing out to do. Okay, so we've got an unknown side, which is this one over here. We know it's going to be this length minus that length, so let's do it. So we know now that this length is 2x plus 1. We can now find the perimeter. Let's see if I got it right. P equals x plus 2x plus 1 plus x plus 2 plus 3x plus 1 plus 3x plus 3. Going around the shape, x, 2x, 3x, 4x, 7x, 10x. 1, 3, 4, 7. There you go, there's the perimeter of the shape. Oh, here we go again. Yeah, let's get rid of them all so I don't have to do this multiple times. It's good to go through lots of cases because you're looking for patterns in what I'm doing, and once you see the patterns, you can't unsee them. And you should find this nice and easy. Let's go. We're not going to look at the fractional stuff. We're just going to look at collecting like terms. A plus A plus A, 3 lots of A. 4A plus 3A, 7A, take A is 6A. 4AC plus another lot of 5AC is 9AC. 4C minus 6C is minus 2C. You end up with fewer than you start with. 1 lot of A squared plus another lot of A squared is 2 lots of A squared. 1M plus another M plus another M plus another M is 4 lots of M. 8C minus 2C is 6C. 2P plus 4P is 6P. 6A take 2A is 4A. 5W plus W is 6W. 9Y minus 3Y is 6Y. 7Y minus 3Y is 4Y. 2W plus 2W is 4W. 7Y plus 3Y is 10Y. And 10 take 9 is 1. 4 lots of S take 1 lot of S is 3 lots of S. 5C plus 3C is 8C. 7S take 3S is 4S. 8A plus 3A is 11A. 3C take 5C is minus 2C. 3A take 5A is minus 2A. 2W take 9W is negative 7W. 3W squared plus 2W squared, 3Y squared plus Y squared is 4Y squared. 2W squared take W squared is negative W squared. It's positive W squared. 2x plus 2x is 4x. 7W take 2W is 5W. 3m take m is 2m. Y squared plus Y squared plus Y squared is 3 lots of Y squared. 7h plus h is 8h. 5k minus 3k is minus 2k. Okay, now that was an absolutely mammoth session, and we did lots and lots of stuff here. But hopefully it's all starting to come together. And you'll find that with a good understanding of algebra, it opens the doors in so many parts of maths going through high school. Thank you everyone, and I hope that helped. Bye.